Hello everyone. Welcome to the May 2024 Unit 2 Section A solution walkthrough. So let's look at question 1, but before that, what I've done for you all is I've compiled all the frequently asked questions and answers for Unit 2, and this covers electricity, waves, as well as nature of light. And the download link is given in the description below. Let's look at question number 1. The temperature of a thermistor and the temperature of a metal wire. So you're dealing with a thermistor and the temperature of a metal wire. And what you have done with the temperature is you have increased the temperature. Now, what do you know about the behavior of thermistor and metal wire when temperature increases? When it comes to thermistors, as temperature increases, the resistance decreases. But when it comes to metal wires, as temperature increases, the resistance increases. So for thermistor, resistance should decrease, and metalware, it should increase. Answer should be B. For question 2, the battery in the circuit shown has negligible internal resistance. Resistor R1 and R2 are identical, right? Which of the following expressions gives the potential difference across R1 in volts, right? So I want you all to look at these two as one component and this the other component. Now try and connect. How are they connected? So these two are in series with this one. Of course, these two are in parallel, I get it. But these two collectively are in series with this one. And what do you know about a series circuit? In a series circuit, the potential difference is shared among the components. So the EMF is 10 volt and R1 or R2, the voltage or the potential difference R1 or R2 would get is 10 minus 3.3. 10 minus 3.3. The diagram shows a ray of light incident at a boundary between oil and water. The refractive index of water is 1.33. Which of the following expressions gives the refractive index of the oil? So guys, a lot of students make this common mistake of recalling N equals sin A by sin R. That is not applicable here or anywhere for that matter. In the new syllabus, what you have to use is N1 sin theta 1 equals N2 sin theta 2. And that's because none of the mediums is air. You can only use N equals to sin A by sin R when at least one of the mediums is air. Since none of the mediums is air, so you cannot be using that equation. So the equation that you use is N1 sin theta 1 equals N2 sin theta 2. And this is arbitrary. Which medium you consider N1 and which medium you consider N2, this is completely up to you, and this is arbitrary. So for this specific question, let's consider N1 to be oil. So N of oil times sine theta has to be in oil. So that is 15 equals N2 would be water. The value is 1.33. It's given here. And sine theta now has to be in water. The value is 17. Sorry, sine 17. So refractive index of oil, that's what the question asked me to find out. So refractive index of oil would be 1.33 sine 17 divided by sine, not theta, sine 15. Sine 15. Let's look up 1.33 sine 17 by sine 15. My answer is B. I repeat, you can only use N equals sine A by sine R when one of the mediums is air. Let's look at question 4. Which of the following is evidence that electrons can behave like waves? So, how did scientists come up with this idea that electrons can have wave-like properties? What they did was they fired a beam of electrons through a graphite sheet, and to their surprise, what they saw was an interference pattern, right? So interference requires superposition and after diffraction, of course. So all of which are wave phenomena, right? So answer is electrons can be diffracted when passing through thin sheet of graphite. The circuit shown includes a cell with internal resistance 0.5. Which of the following expressions gives EMF in volt of the cell? So my suggestion for all the candidates is make sure when it comes to unit 2 you have all of the equations at the tip of your tongue, because if you forget the equation and if you have to look back at the equation booklet, that exam is not going to be the best of exams. You have to have all of the equations memorized. So for this question, the equation you'll be using is that of potential divider, because this EMF, let's call this EMF, this EMF is shared between the 0.5 ohm internal resistance and the 6 ohm load resistance, right? So for this equation would be V1 by V2 equals R1 by R2. So again, which one you consider V1, which one you consider V2 is arbitrary. So for this specific question, let's consider the potential difference across the 0.5 ohm resistor to be V1. So let's say this is V1 by V2 would be 1.2 equals the corresponding, let's say this is V1, right? So this would be 0.5 R1 divided by, and the corresponding resistance of 1.2 would be 6. So make V1 the subject. V1 would be 1.2 times 0.5 divided by 6. But that's not what the question asked you to find out. The question asked you to find out the EMF, right? And you all know these two are connected in series. So what happens is this EMF is shared between 0.5 and this 6. So EMF would be equal to potential difference across 0.5 ohm resistor and potential difference across 6 ohm resistor, right? And you already know the potential difference across the 6 ohm resistor is 1.2. So the EMF would be 1.2, this one comes over here, plus the potential difference across 0.5 ohm would be 1.2 times 0.5 divided by 6, which we just found out. And look over here, then C, not D. Let's move on to the next one. Which of the following describes threshold frequency? So it's a very basic definition. It is the minimum frequency that causes photoelectric effect. And the other term for photoelectric effect is electron to leave a surface. So it is the minimum frequency of light that can cause an electron to leave the surface. Answer is C. 7. Quite complicated. So let's see. The diagram shows part of an electric circuit. Which of the following expressions gives the total resistance in ohm between X and Y? So they're asking for the total resistance, but this is not a series circuit or a parallel circuit. This is actually a combination circuit, and I've seen a lot of students struggle with these type of questions. So for these, my suggestion is do in steps. Solve these in steps, everybody. For example, let's first find out the resistance in the series part. So resistance in the series section, like this is in series, is just 2 plus 3. Why I am not writing 5 is because they're not looking for the value, they're looking for an expression. Now, consider these two and see how these two are connected with the 4 ohm resistor. So 2 and 3 are in series with, sorry, are in parallel with 4, right? So resistance of the parallel circuit would be, actually recall the equation, 1 by resistance in parallel equals 1 by R1. Let's consider this to be R1, 2 plus 3, plus 1 by, let's consider this to be R2, 4. So what you got here is not Rp, as in resistance of the parallel branch. This is 1 by Rp. So you have to inverse the whole thing. So resistance of the parallel branch would be inverse of this whole thing. 1 by 2 plus 3 plus 1 by 4. Now you have the total resistance of this section, and consider how this is connected with this. These two are in series. So RT would be this value, 1 by 2 plus 3 plus 1 by 4, plus, since this is in series with this one, you just add 6 here. So that is RT, as in the total resistance. So my answer is D. Next, there is tension T in a string of length L. When the string is displaced and then released, waves move on the string with speed v. So just by looking at this, you recall this is a question related to standing waves. And how is tension and speed on a standing wave related? It's related by the equation v equals to root over t by mu. Let's just put it over there. Now, a string of length twice L has the same diameter and is made from the same material. So if it has the same diameter and the same material, it will have the same value for mu. Mu is mass per unit length. The length has doubled, I get it. But since the diameter remains the same and the material remains the same, as the length increases, mass increases proportionately, right? So the value of mu remains the same. This is a very important point to address for this specific question. Which of the following expressions gives the speed of the waves on the string of length twice L? Okay. So for twice L has no effect actually. What you have to look for is what happens to the tension. So the new V, Vn, equals root over, now the T has become twice T over, but since we have already established that the mu remains the same, twice T by mu. What you have to do in this type of questions is turn the new quantity in the form, as in express the new quantity in terms of the old one. So I have to bring this in the form of root over t by mu. But the obstacle I have is 2, the extra 2 over here with the root over it. So you remove root 2, and what you're left with is root over t by mu. But guess what? Root over t by mu was my initial velocity. So the new velocity would be root 2 times v. My answer would be C. And again, my suggestion, have all of the equations memorized. Let's go to 9. The student connects the circuit shown. The resistors all have different resistances. Which of the following expressions gives the current in amps in resistor R? Okay, you start from here, everybody. So consider the 4.7 ohm resistor. How is this one connected to this battery? They are connected in series, right? So when it comes to a series circuit, we know that the same current flows through all the components connected in series. So the current that will flow through the 4.7 ohm resistor is the same current that flows to the battery, and you can also call that the total current, right? So IT, and I put it in this direction because this is the positive terminal. Current always flows from the positive terminal, right? So IT would be equal to, recall the equation, the basic equation, V equals to IR. So I equals V by R. So this is my V, 1.4, divided by R is 4.7, right? Okay. Do you know what this point is, guys? This is my junction. And what happens at a junction? Current either gets added up or divided at the junctions. So this is the total current rate, and this will get split into two parts. One will flow through R, the other one will flow through this section, and you already know the value of this current, that is 0.13. So my total current, IT, is split into two parts. One goes through R, the other one goes through this resistor. So IT equals current through R plus 0.13, because you already know the value, 0.13. So IT is 1.4 by 4.7 equals IR plus 0.13. And the question is asking you to find out the current through R. So IR would be this minus 0.13. So 1.4 divided by 4.7 minus 0.13. Let's look. 1.4 by 0.7 minus 0.13. Answer is A. Next. This is really complicated, right? So let's see how you should be thinking during your exam. Light of wavelength lambda traveling at speed c is incident on a metal surface. Photoelectrons are emitted from the surface with a maximum kinetic energy. So this half mv square, you just think of this as EK, right? Okay. The graph shows the relationship between 1 by lambda and kinetic energy. Which of the following shows how the gradient of the graph can be used to determine the Planck constant h? Right. So for these type of questions, my suggestion is go back to the basics. So recall the equation of photoelectric effect, Einstein's famous equation for photoelectric effect. It is energy of the photon is equal to work function plus kinetic energy. And this is basically that kinetic energy. Okay, right? Now, since they have expressed this in terms of lambda, recall how photon energy can be expressed. There are two ways of expressing photon energy. One would be in terms of frequency, which is E equals hf. The other one would be in terms of wavelength, that is E equals hc by lambda. So let's turn this and let's express this in terms of lambda. So the photon energy becomes hc by lambda equals, let's bring kinetic energy forward, kinetic energy plus you have phi. Let's isolate 1 by lambda from here. So hc times 1 by lambda equals kinetic energy plus phi. So let's make 1 by lambda the subject. So hc goes here, 1 by hc into ek plus phi by hc goes down as in hc. And you know what, guys? This is in the form y equals mx plus c. And this is what they have used to plot this graph. So in the y-axis, we have 1 by lambda. In the x-axis, half mv squared is basically the kinetic energy. So the gradient of the graph, right? So the gradient of the graph would be equal to 1 by hc. So the question asks you, how would you calculate Planck constant, which is h? So make h the subject. H would be equal to 1 by c, and the gradient comes here, times. So h equals 1 by c times gradient. Answer is B. Thanks for watching and good luck.